Okay, the corresponding angles converse theorem says that if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Okay, so with this lesson, what we're doing is we're working our way backwards. That's why it says converse. We've switched the hypothesis and conclusion of what we did when we talked about parallel lines cut by a transversal. So what this means is if you have a pair of corresponding angles that are congruent, like if I told you somehow that we knew that angle 2 was congruent to angle 6. Okay. So here's what we're saying. If angle 2 is congruent to angle 6, then my conclusion now is going to become that line J is parallel to line K. Okay, so we have example 1 that says find the value of x that makes line M parallel to line N. Okay, so on this lesson, we're not told that these lines are parallel, but we want to say what value of x do I need so that I can say, or I can conclude that these two lines are in fact parallel. So looking at these two angles, these would be corresponding angles, and if I want these two lines to be parallel, that means these two angles have to be congruent. So to figure out what value of x we need to set these two equal to each other. So I would say 3x plus 5 is equal to 65. I subtract 5 from both sides. Tells me 3x is 60. Dividing by 3 tells me x is going to be 20. Okay? So when x is 20, these two lines are parallel. Okay, now we're going to look at the other three angle relationships that we had talked about previously, but we're going to list them out just so you can have them and write them down. The alternate interior angles converse theorem says if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if you can somehow if they tell you angle 4 is congruent to angle 5, that means line J and line K are parallel. The alternate exterior angles converse says if two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are parallel. So again, if angle 1 is congruent to angle 8, that means that line J is parallel to line K. Okay, then we have the consecutive interior angles converse. It says if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Okay, so if we know that measure of angle 3 plus the measure of angle 5 equals 180, then that means that line J is parallel to line K. Alright, so example 2 wants us to prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Okay, so here's the drawing for it. They went ahead and gave us that angle 4 is congruent to angle 5. So in our picture we would have that little arch here, an arc there to show that those two angles are congruent, and they want us to prove that G is parallel to H. Okay, so to start our proofs, remember that we need our statements and our reasons. Okay, and we always start with what's given to us. So the first thing they told us was that angle 4, or the only thing they told us was that angle 4 is congruent to angle 5. Okay. Then they have this angle 1 up here. Now, I know angle 1 and angle 4, those are congruent because of vertical angles. Vertical angles are always congruent. And then I could say that 1 is congruent to 5 by the transitive property. Okay. Because I said 4 is congruent to 5 and I said 1 is congruent to 4. So since 1 and 5 are both congruent to 4, they would have to be congruent to each other. So then I could say that line G has to be parallel to line H by the corresponding angles converse theorem. that we just looked at. Example 3 says in the diagram R is parallel to S, and we know that angle 1 is congruent to angle 3. We've got to prove that line P is parallel to line Q. So let's start our proof. Going to make our statement column and our reason column. And we always start with what's given, so I know that R is parallel to S, that's given. And we know that, well, let's not use this angle 1 congruent to angle 3 yet. Let's just say that R is parallel to S. So I have this line R, I have this line S. I want to ignore for a minute this line P. We'll pretend like if it weren't there. Okay, just so you can see it. This line Q is going to be my transversal. So if R and S are parallel, I know that angle 2 is congruent to angle 1. Because of the corresponding angles theorem. Okay. All right. Now, scroll this back up here. Now we can use that second given. I know angle 1 is congruent to angle 3 because that was given to us. Okay. So I know that since angle 2 is congruent to angle 1 and angle 1 is congruent to 3, that means that angle 2 has to be congruent to angle 3 by the transitive property of congruence. Okay. Now, if angle 2 and angle 3 are congruent, if I ignore now this side for a second, if I ignore this line RS, okay, if I know 2 and 3 are congruent, then that tells me that line P is parallel to line Q by the alternate interior angles converse. Okay. If these two angles are congruent, that means that these two lines, line P and Q, have to be parallel. Next we have the transitive property of parallel lines theorem, and it says if two lines are parallel to the same line, then they are parallel to each other. So like in this example here, if I know that line P is parallel to line Q and line Q is parallel to line R, then that must mean that line P has to be parallel to line R also. Example 4 says in the diagram below, line P is parallel to line Q and line Q is parallel to line R, and we want to find the measure of angle 8. Okay. So because of that parallel lines transversal theorem, I know that P is parallel to P is parallel to Q, and I know Q is parallel to R. So that tells me all three of those lines are parallel to each other. So corresponding angles would tell me that if this angle right here is 115, that means this one right here has to be 115 degrees. Okay. And if this is 115, that means this right here has to be 115. Because they would be corresponding. If I ignore this line P up here, these two would be in the same position. So they would be congruent. Now, this line right here, this gives me a linear pair. So I know that the 115 plus the measure of angle 8, those two together have to be 180. So if I subtract 115 from 180, that tells me the measure of angle 8 is going to be 65 degrees.